that are being taken by the UAE government and industry to make this vision a reality. I hope you find this presentation by the following speakers informative and engaging, and that it will inspire you to talk about the ways in which we all contribute to a more sustainable future. Thank you for joining me today, and let's get started. Our first speaker is Dr. Shawki Lanal, professor from the University of Sharjah, and he has a presentation here with us that he would like to discuss. Please, the floor is yours.
Everyone. It's really a pleasure to be with you today to participate in this event on topic about net zero emission in UAE and the role of green hydrogen. My name is Shawki Lanal from the Sustainable Renewable Energy Engineering Department, College of Engineering at the University of Sharjah, and also the coordinator of the Renewable Energy and Energy Efficiency Research Group. So we have a Sustainable Energy and Power System Research Center at the University of Sharjah. And also I'm chairing the Energy and Climate Change circles for the Sustainability Office, using different sustainability projects at the University of Sharjah campus. For the presentation today, after my talk, I would just, because we are limited with time, just quickly show you the challenge that we have with the problem with the CO2 emission from the combustion of fossil fuel. I will share you some data from the International Energy Agency about energy-related CO2 emission. I'm going to talk also about the net zero emission. I'm going to show you today the roadmap to the global energy sector. So if we look globally, how we can reach the net zero emission by 2050. After that, we're going to talk about what is the UAE National Energy Strategy and the strategic initiative for net zero emission or clean energy transition by 2050. We talk after that about the role of green hydrogen, how important in this clean energy transition and net zero emission. And after that, we'll focus more on the challenges that we have with the hydrogen in general and green hydrogen. And we're going to talk what are the research and development needs. So we have a lot of challenges and what are the innovation technology needed. And after that, we'll finish with the summary conclusion about that. So these are some facts, some data that we have about the global. So here we're going to start with the global energy sector and what's the energy-related CO2 emission that we have. So if you look for the graph, the one at the top on the left, it shows that the greenhouse gas emission, this is in gigaton of CO2, how it's increasing globally from 1900 to 2020. So if we continue the business as usual, as you can see, because we are using mainly fossil fuel, the CO2 emission will increase. And what you can see also on the top here in 20, what happened? We saw a decrease in 20. And what was the reason of this one? Because of the COVID-19, because we have a lockdown, and since we have the lockdown, we reduced the energy consumption or the demand of energy, and since we need to keep the balance between the supply and the demand, the supply also decreases. That's why we had a decrease about from up to 33.6 gigaton. And what happened after 20 with the opening after the COVID? Now we go back to the increase of the CO2 because the energy consumption increases again. And the increase was about as you can see in red color here in yellow. If you look for each sectors, as you can see in 2020, so this is the bottom left, the CO2 emission for all the sectors, say electricity generation, for transportation sector, for building and for industrial application, all of them decreased in 20 because of COVID-20. But if you look for 21, you can see we increased again the CO2. So this is not sustainable, especially if we have a target strategy for net zero emission by 2050. So we start decreasing the CO2 emission starting from 2020. If you look here from the right side from the bottom, biofuel also, you can see the CO2 emission is increasing for all the fossil fuel. Coal, we are using coal and natural gas for power generation and also for oil for transportation system. So this is not sustainable. So we have to move to developing a clean energy system to reduce the carbon footprint if we want to reach the net zero emission by 2050. So we have to go with the net zero emissions. So each country, so what will show you the data is CO2 emission. You have to do the same thing. Look for the CO2 emission here in UAE. What are the energy sectors that are producing CO2? And you have to develop a strategy to reach the goal of net zero emission by 2050. So what is net zero emission? Is the removal of equal quantity of carbon dioxide, CO2 from the atmosphere as it released in. So we need to develop now clean energy technology using the renewable energy, energy efficiency. We have to go some behavior changes through energy conservation to reduce the waste of energy. Electrification is very important in the energy mix. Carbon capture, utilization, and storage also is very important because we will continue to use fossil fuel. So we have to develop technologies to capture and store the CO2, or maybe find a way to turn these challenges that we have with the CO2 to new opportunities because we can use it for different applications. And low carbon that means biofuel, and zero carbon fuel like green hydrogen, green ammonia are very important if we want to reach the target that we have for net zero emission by 2050. See how we do it? We have different strategies, different technology that can be used. So we're not relying on one technology. It's not only hydrogen. So it will be a mix of different technologies. So we have to go to renewable energy system, and we have different technologies. So you have to select the right technology that can be used for each country. Here in UAE, it's mainly solar PV, solar thermal that can be used to produce electrical power. So we have to go with the renewable because it's a clean energy system. Energy efficiency is very important. So energy efficiency is very important also for the energy mix. We need to improve the efficiency of the energy system. If you look for the UAE strategy, by 2050, we need to improve the energy efficiency by 40%. Okay, the clean energy should be 50% by 2050. And of course, electrification of industrial process, transportation, carbon capture sequestration, pre-combustion, during the combustion process, how we can control the carbon footprint, and also post-combustion technology. So this is if we continue to burn the fossil fuel. And of course, other one, efficient means of transportation, carbon tax and emissions. So these are some of the strategies that can be used to reduce the carbon footprint. In addition to that, alternative fuels are very important, biofuels and zero carbon fuels like green hydrogen and green ammonia. So this is the data. As I said, this is the scenario. So we have to come up with scenario. You have to see what we are right now. So if you can start with the baseline in 2020, what is the CO2 emission globally, for example, in UAE? What are the different energy sectors that are producing the CO2 emission? And you need to develop a strategy, scenarios, by including this clean energy technology to reach the goal of net zero emission by 2050. This is an example for the global energy sector. This is the roadmap for global energy sector. This is from International Energy Agency. And you can see this is what we are in 2020. What about 33.6 gigaton of CO2? And you need to work on all the sectors for building, transportation, industry, power generation, to put strategy to reduce the carbon footprint for each energy sector. And what you see here, these are the strategies, okay? So you need to increase the number of electrical vehicles, for example, by 2030, 50% for the electrical vehicles should have, for example, for transportation. We need to work on renewables. What is the renewable electricity fraction that we are using right now in 2020? What do you want to reach by 2030? For example, 50% of the total electricity that we are going to generate will come, for example, from solar and wind, for example. Okay? And what you can see on the bottom side, they have different strategies, including renewable energy, energy efficiency, carbon capture, sequestration, electrical vehicle. But since we are talking about the hydrogen, what you can see in purple at the bottom is the amount of hydrogen that we need to bring in the energy mix. Okay, so this is an example. For example, by 2030, we need about 140 or so million ton of low carbon hydrogen in the energy mix. Okay, so by 20, for example, 45, we need 425, for example, or so million ton of hydrogen. So by 2050, we need about 500 million tons of hydrogen that will be included in the energy mix. Okay, so as I said, these are the scenarios that we have to reach at the end. The net zero, as you can see, will reduce completely the CO2 if we go through the strategy. So you have to set some key performance indicator, and you need to track this performance every 5 years or 10 years, see where you are, and sometimes you have to adjust it, include the new technology. But all what we can include, what we included here is a clean energy technology to help us to reach the net zero emission. And from the right side, you can see here examples. For example, for power generation, electricity generation, it was on 20, let's say 2061% is coming from fossil fuel. But if you look for 2050, for this strategy, this scenario from the International Energy Agency, 88% of the electricity should be produced from renewable energy. So you can see it for electricity generation, for building, for industry, and also for transport, for vehicle, aviation, and also shipping. So that's what it will include, and you can see here the annual CO2 emission reduction. So there will be some behavior changes. As I said, we have to reduce the waste of energy, even if it's a small percentage. We have to use technology in the market, existing one for renewable, for green hydrogen, for carbon capture, sequestration. And what you see on the top is a technology under development. So we need to continue to work to do more research and development to develop new technology to reach this net zero emission by 2050. Anyway, this is the scenario. As you can see, 2020, 2030, 2040, 2050. This is for the global energy. So in UAE, we have to do the same thing. We have to set strategy, and we have to develop clean energy technology, including the renewable energy efficiency, green hydrogen, carbon capture, and we need to track the CO2 emission reduction. As you can see on the first one, 2020, it was 33.6 gigaton of CO2. And because we took actions here with the clean energy transition, we reduced it to the CO2 emission to 21%. And we will continue to work on that. So you can see in 2040 is about 6.3, the global, and you can see the shrink of the circles, that is the total amount. We are reducing the CO2 emission. The blue one is for power generation, the yellow one for transportation, for industry, the green one, and the building is the purple. So we have to focus on all the energy sector, and we have to use all what is available in the market for clean energy technology to reach at the end. You can see the net zero emission, and you can see the percentage of, for example, the renewable. For example, almost 70% of electricity generation will come from solar and PV. Green hydrogen or low carbon hydrogen, 520 million tons. So you see it's included in the energy mix, the low carbon hydrogen. So it's an important factor to reach the net zero emission, and we have to work on building, transportation, industrial application. So these are scenarios, okay, based on the resources that are available for each country, based on the available technology, based on maybe technology that we are working on to be maybe available in a few years, and based on that, you can develop a scenario to reach the net zero emission. So if you look now for the UAE, so we are talking about net zero emission in UAE. So this is the UAE National Energy Strategy by 2050. I put from the left side the state of the energy sector in UAE in 2020 from the International Energy Agency. So as you can see, most of the fossil fuel is the main fuel used for all the sectors. From the left side, you can see the fuel that we are using. From the right side, you can see the different sectors for transportation, for industry, for buildings. But you can see we're relying more here in UAE on oil and natural gas for all the energy sectors. So if we want to set target by 2050 to reach the net zero emission, we have to reduce the fossil fuel and we have to include the new clean energy technologies based on the strategy that we have here, based on the resources available here, for example, solar energy, and based on the technology that's available in the market. From the right side, you can see the final solution for the national energy strategy by 2050. So there is a strategy, there is a number. For example, 50%, if you include renewable energy and nuclear energy, 50% of the total energy will come from clean energy system, using the renewable and nuclear. Okay. There will be also energy from gas and clean fossil fuel. And you can see energy efficiency 40% increase. Blue and green hydrogen is also in the energy mix, production and export also from UAE. So these are the energy to reach the clean energy transition, to switch from conventional energy and power system using conventional energy systems that are based on the fossil fuel to clean energy system, to reach the net zero emission. So these are some strategies: renewable energy, nuclear, clean fossil fuel, energy efficiency, electrification, which is very important, green and blue hydrogen, and carbon capture and storage and utilization. So this is also, now if you focus on green hydrogen, because the previous one is the clean energy transition and the net zero emission. So now if you focus on green hydrogen or hydrogen strategy in UAE, so these are examples of what needs to be done. So there is a possibility to produce hydrogen in UAE for both blue and green hydrogen. Because the blue is based on the natural gas, which is available here, okay? And also the green hydrogen, we have enough solar energy, so we can use solar PV to produce this green hydrogen. So this is very important, and green hydrogen should be included in the net zero emission. And if you look globally, the hydrogen, the clean hydrogen, should be between 12 to 20% of the energy demand by 2050. See, that's why we have to develop strategy to include both the blue and green hydrogen. We have to move, of course, to green hydrogen, but this is very important for climate change. If you want to reach the net zero emission, it's very important also for energy security. Why? Because this green hydrogen, this kind of fuel can be produced locally. So you don't rely on fossil fuel coming from outside. So you use renewable energy, you use wind energy to produce your own fuel locally. See, now, as we can see what's going on in Europe, now green hydrogen, renewable energy, it's not only important for climate change, but it's very important for energy security. There is a massive potential also to use this in UAE because of the solar radiation that is available here in UAE, and natural gas that can use it for blue hydrogen. There is an international momentum also. Example here, 45 countries with the national hydrogen strategies. So we need international collaboration. It's very important, and it will help to improve the economy because it will hydrogen economy is very important to create new jobs. And there are a lot of research and development needed, as I'm going to explain later, for fuel cell, for electrolyzer, for hydrogen storage, for application, for different applications. So there are a lot of room for research and development and developing innovative technology related to hydrogen. So these are some projects. So it's not only talking about the hydrogen, it's not only on the paper for the strategy, but there are some real projects all over the world, and of course, I put here a graph about the GCC and one about the MENA, Middle East and North Africa. So these are hydrogen projects. Some of them are blue hydrogen, some of them are green hydrogen. So you can see in UAE, there are at least 4 to 5 ongoing projects. Some of them, they are under development, some of them are in the procurement, and some of them, they start already the operation. And you can see also the capacity of each project, where we're talking before globally to reach the net zero emission by 2050. Globally, we need 520 million tons of low carbon hydrogen. So here you can see some of the products they are producing 2 million, 0.5 million. So this is very important, and we have already ongoing project on green hydrogen, and this will be part of the clean energy transition here in UAE and also the net zero emission Same thing, these are some projects for the Middle East and North Africa. So you can see the United States, United Arab Emirates is regional leader when it comes to clean hydrogen, as you saw some of the ongoing project. Green hydrogen will play a role to reach the goal of Paris Agreement with respect to the climate change. We have the COP28 here in UAE, November, December. So these are the conference of parties where there will be some pledge for each country to reduce the carbon footprint. They have to put the strategies. So this is very important for that to reach to boost the clean energy transition and also to reach the zero emission by 2050. Green hydrogen is very important for decarbonization, clean energy transition. This is the number, as I said, 420 million tons per year. This is what needed in the energy mix globally. So UAE, we have to define also, we have to figure out how many million tons of low carbon hydrogen needed to reach the net zero emission by 2050. And it's efficient because if you look for the energy density or call it calorific value of the hydrogen, it's 120 megajoule per kilogram. So if you take 1 kilogram of hydrogen, you burn it, for example, in gas turbine, it will release a higher energy, 120, compared to fossil fuel, like natural gas, about 40 to 50 megajoule per kilogram. So there are so many advantages of using hydrogen. So this one is the role of hydrogen for the clean energy transition and energy net zero emission. So hydrogen will play an important role for the energy transition and the development of net zero emission. So the clean energy transition is very important also, how you can move from conventional power system to new energy system. And there is a ranking by countries. So here you can see where you are compared to the other countries all over the world. And they use some key performance indicators, as you can see here. Some of them relate to system performance, some of them are transition readiness. For example, system performance, they use security and access to energy. Environmental sustainability is related to climate change, and economical development and growth. So they have some key performance, and you get the score related to system performance. And the readiness score also clean energy transition, as I said. So you get some numbers, and they do a ranking, and this one helps you to see what are the weaknesses. I need to work on that to improve your ranking. So they do it. This is from the World Economic Forum. So renewable, why green hydrogen is important? Because we are using renewable electricity to produce hydrogen. Not only the hydrogen, the fuel that we are using is clean. Whatever you use it in the fuel cell, in gas turbine, by the way how we are producing is clean also because we are using renewable energy. So this will help to cut completely the CO2 emission for the whole life of the green hydrogen. So there is also large green hydrogen application potential because we can use for power generation, we can use for buildings, for heating, or for power generation. It can be used for transportation, for vehicles, for aviation, for shipping also, and for industrial applications. So there is a large market for the use of green hydrogen. Green hydrogen is gaining also momentum in the public and the private sectors. And so the clean hydrogen economy is possible with further technology innovation. This is very important. So we need innovation technology, as I said, for the production of hydrogen, for the use for the fuel cell, for the storage, and also find different applications. So these are the chose the green hydrogen, what we need to do. As I said, for the production, transformation is important also, transport, and the use. So we need innovation technology for all of them. So the way how we produce it from the beginning, using solar PV, for example, we want to use solar PV in UAE. We have so many challenges for solar PV here. The first challenge that we have is the solar PV, the efficiency is low. We're talking about 20%. What this means, from the total energy from the sun, only 20% will be compared to electricity. In addition to that, we are in the desert region. We have the effect of the dust, effect of the temperature, that will reduce the power out. So we need to work also on technology for cleaning the panels, for cooling the panels. Because if we improve the power out from the solar PV, we will reduce the cost of electricity from renewables, and this will help to reduce also the cost of hydrogen production. This is one of the challenges that we have, is the cost of green hydrogen is very, very high. Transformation also, what's good about green hydrogen, you can use it directly for different applications, and you can produce also alternative fuels, like synthetic fuel. So if you capture the CO2 from power plant using fossil fuel, you combine it with green hydrogen, you can produce synthetic fuel. You can produce methane, which is similar to natural gas, so you can inject it in the pipeline for natural gas, and you can produce also methanol. Okay? If you want to go with green ammonia, so you have to separate the nitrogen from the air, combine the nitrogen with green hydrogen to produce ammonia. After that, you have to work on the storage. Storage is very important also. You have to store your hydrogen to be used, for example, for electrical vehicles. For transportation, when the business will grow, so there will be some shipping going from one continent to another, let's say from Africa to Europe. So now Europe, they have a need for natural gas. So there are already some MOU signed to ship in the future the green hydrogen from North Africa to South Europe, Italy, Spain, and this stuff. So we have to develop also technology for transportation of this green hydrogen, and you can see from the right side different applications. That's what's good about the hydrogen, so we can use it for industrial application, for transportation sector, for building, for heating, and for power generation. On the right side, I put here some numbers that we are already using green hydrogen. It's not maybe green, but the hydrogen, there is a huge demand for it for industrial application. Okay, so this is the hydrogen consumption in 2020 in million tons per year. Okay, so this is from Ireland. So there is a demand for industrial application, but now we have to increase the market from other application. So these are the challenges. I'm going to just review the challenges for green hydrogen production, storage, transportation, and use. So these are some challenges that we have. We need to work on that. So that's why we need more research and development related to this fourth area. Production. Right now, the cost of green hydrogen is high. Okay, so the blue hydrogen will cost maybe only $2 to $3 per kilogram. The green hydrogen can cost $6 to $8 per kilogram. So we have to set some target. So we have to do some research and development. United States, for example, they put the target. They call it 1-1-1. In 1 decade, 10 years, they want to reduce the cost of 1 kilogram of hydrogen to $1. So they already set the strategy. They are doing the research, and that's how they can reach the goal. So we need to do a lot on electrolyzer for producing green hydrogen, commercialization on large-scale deployment, so we need to scale up the electrolyzer, improve also the efficiency. Right now it's between 60 to 80. If we can improve the efficiency of converting water, splitting the water in hydrogen and oxygen, and also working on the efficiency for the other technology. The same thing for hydrogen storage. There are a lot of research and development that needs to be done. Hydrogen transport distribution, and also hydrogen and use, different applications. Okay? For each application, I will just give you the example of gas turbine. Okay, gas turbine engine. So if we want to switch, because if you take, for example, just take an example in UAE, EGA, Emirates Global Aluminium. This is one of the top companies in the world that is producing aluminium, but they are using a lot of energy. And the energy that they are using from natural gas, they are using combined cycle, using Triton and steam power plant. So if we can switch from natural gas to green hydrogen or hydrogen for the combustion in gas turbine to produce electrical power, so this will reduce the amount of CO2 from this industrial company. But we have some challenges. For example, switch from natural gas to green hydrogen, higher flame temperature, so the temperature will increase. So we need to develop the right material for the gas turbine, for example, the blade, the combustion, flame stabilities, okay, and higher NOx emission. So we want to switch to hydrogen because it will help to reduce the CO2 emission, but we have so many challenges, and we need to work on that by doing more advanced research and development. So these are some research and development just weekly about innovation technologies. As I said, we need innovation technologies for the way how we produce hydrogen. As you can see, we have different technologies that we can use. Natural gas reforming, steam reforming, biomass gasification. So these are low temperature electrolyzer. But now research and development, we are working on high temperature electrolyzer. Because when you work on high temperature, the energy, the electricity needed to split the water, we are going to minimize that energy. And this will help to improve the efficiency of splitting the water in the electrolyzer. So these are some technology, they are still in the research and development. This is for long-term strategies. We have to check different type of electrolyzer. For storage also, we need to do a lot of research and development for storing the hydrogen either through compressed gas, liquefied hydrogen, or using metal hydride, for example, hydrogen. For the application, we have to look also for different application and look for the challenges. I gave you one example before using hydrogen in gas turbine. So we need to do a lot of research here with respect to combustion process, to the material that we use for hydrogen. So there are a lot of research and development. And the last one also is transportation of green hydrogen or hydrogen is very important also. So we can transport it maybe blended, for example, 80% natural gas with 20% hydrogen. And this one is just to show that there are some momentum also for hydrogen-related patents. This is from 2010 to 20. So not only we need to develop, to do research and development, but we have to come up with new product, new systems. So you see the number of patents, and as you can see here, a large number of patents relate to fuel cell. That's why we use the hydrogen to produce electrical power. There is hydrogen production in electrolyzer, which is 36% of the total patents. Hydrogen storage, which is 21. Hydrogen distribution is only 2%. So now quickly 2 slides just to finish with my presentation. This is what we are doing at the University of Sharjah. So we're working on testing the performance of green hydrogen production, and we are trying to find ways how we can improve the efficiency here under UAE weather conditions. So the conditions are completely different. We did experiments in Europe or USA, it's completely different from here. So that's why we need universities in UAE, research and development teams, research institute to work on a lot of research to boost this hydrogen research. See, what we are doing, we're doing an optimization for green hydrogen production and storage. See, as you can see, the first thing that we are working on, we're using different technology for solar PV. We're using the bifacial solar PV. It's a solar PV where you can produce power from the front and the back of the solar PV. Because if you use a regular solar PV with a mono, you produce only from the front. So if there is a reflection of the light from the ground of the roof of the building, on the back of the panel, it will not produce anything, and it will add more heat that will reduce the power. See, what we are trying, the reflection that we get from the roof of the building, we put the bifacial, so now we are producing from the front and the back. So this will help to boost the power production by about 20%. But there are so many parameters that we need to use there to optimize the power out. See, the tilt angle is important, the height from the ground is important, the albedo, which is the color that we put in the roof. As you can see, we are testing different colors in the ground of the roof of the building, white, gray, and green. So if you put a white with white color, you can reflect more light. So we can get up to 80% reflection, solar reflection from the ground. So this will help to boost completely the production. And you can see from the results that we tested here, what you see in yellow is the bifacial solar PV with white coating. And the one from the bottom is the monofacial. So we can see, I put also the percentage where we're able to increase the power out from this solar PV by 28%, which is a huge amount. And after that, solar PV is used, it goes to microinverter because we have to convert the DC power to AC. And after that, it goes to PL electrolyzer to produce hydrogen. We store it here in the hydrogen tank. We're using metal hydride. And after that, we are testing also fuel cell, and we have a load simulator. So this is a small prototype experiment that we are doing in the lab. We are simulating the electrical power need through the load simulator. And we are simulating a case where you will use solar PV during the day, for example, to meet the electrical load of a building. And the extra power that you get from the solar PV, use it to produce hydrogen. The hydrogen will be stored in the tank. And during the night, where you don't have a solar energy, now you can use the hydrogen tank, take the hydrogen from the tank, it goes to the fuel cell to produce electrical power, and use it during the night for the load. So we're trying to optimize the whole system. So there is the production, there is also the storage. The way how we are storing also the hydrogen in the tank is very important. So these are some graphs that shows how the pressure is changing in the tank and what's the flow rate of how many liters per minute of hydrogen they are producing. When you charge the tank with hydrogen, the temperature inside, it's a metal hydride, will increase. So you have to develop a thermal management system to manage the temperature of the storage system. During the charging, because the temperature will increase, you need to cool it. And during the discharge, during the night, when you discharge your tank, What happened, now the temperature will decrease, so we need some heat during the discharge. So we need to develop a thermal management system to control the temperature of your storage system, and this is what we are working on right now, developing a thermal management system to manage the hydrogen storage. So these are like some examples, and these are the system. The system is very small, it's about 1.2 kilowatt electrolyzer, as I said, for laboratory scale experiments. We do also feasibility study, which is modeling and simulation analysis. This is an example that we did in the north of Africa, Algeria, the desert of Algeria. And we selected the region where there is enough solar energy and there is wind. So now what we want to maximize the renewable electricity that we generate using all the resources. There is enough solar energy, there is enough wind. So we develop a hybrid solar PV and wind to produce electrical power to meet the load of 1,000 houses that we selected there in the region there. So we put some load that is 15,000 kilowatt hours per day. That's used for HVAC, for cooling, for lighting, for appliances, for 1,000 houses per day. But we added a hydrogen load. So this system, it's 100% renewable. Will be used to meet the load, electrical load, but we are adding some hydrogen that we produce there for transportation and for other industrial applications. Okay? See, the solar PV and wind will be used to meet the load, electrical load. Part of the extra or excess power from solar PV and wind will be used to power the electrolyzer to produce hydrogen. The hydrogen will be saved or stored in the tank to be used during the night. Or when there is no wind. So the fuel cell is used there. And you can see, we were able to see the performance of the system there based on the weather condition there. So we can see the amount of hydrogen that we produce from the electrolyzer, the amount of hydrogen that's used in the fuel cell, what's the power out from the solar PV, the power out from the wind. And so this is, you do it per day, this is few days, let's say from June 1st to 7th, and you can look for the power consumed by the electrolyzer for the whole year, what's the green hydrogen that you produce. Okay, so you can see the performance of the whole system. These are feasibility studies before you design the system. And what's good also, we added to it, because it will help with decarbonization, because we reduce completely to zero, because it's renewable electricity. But decarbonization by itself is not enough. So we have decarbonization. The system is also decentralization of the energy system. We don't take anything from the grid. Plus, digitalization is an important also key factor for decarbonization. So we have to put a smart meter to collect the information about the system in real time and use this system for developing advanced control system to optimize the system, to do forecasting. For example, here we did forecasting, because the green hydrogen that we produce, it depends on the solar and the wind. And these are intermittent resources. They are not there all the time. So you will be able, using the data, do forecasting model to forecast ahead. Using historical data, using the weather data, so we'll be able to forecast ahead. 1 hour, 2 hours ahead, with the system I can tell you what's the amount of hydrogen that we produce from that, or what's the amount of power that I'm going to get from solar PV, or the power that I'm going to get from wind turbine. So this is important. Prediction or forecasting using artificial intelligence and machine learning is very important for developing this kind of technology and optimization of the system. So summary and conclusion about the presentation. So hydrogen will play an important role. It can be blue or green. Of course, we want to go with green in future energy system because it's clean, and as said also for energy security. It's very important here. And it's the moment now to go to set some strategies and start working on that. There are many pressing energy problems that can be solved with help of hydrogen, especially industry where the CO2 emission is high. Switching to hydrogen will help to reduce the emission, to boost the clean energy transition, and net zero emission. I put some number. I think this is what we need. Between 20% of the total energy demand globally will come from hydrogen. Hydrogen is used right now for industrial application. So you can see 74 million tons was used in 2018, but we need to increase the number of applications for the target area like cement, steel, aluminum, and oil and gas company. In addition to that, hydrogen needs to be adopted in area where it is almost completely absent. As I said, it's used mainly for industrial applications, and we use it now for transportation, vehicle, shipping, aviation, building, for boilers, for those who need the heating, or we need it also for cooling, fuel cell, power generation for fuel utility. We want to reach the net zero emission by 2050. There is growing also support, financial investment in hydrogen-based technology, increase the government funding for hydrogen industry research and development. This is very important. Okay, so you have to set a strategy. What they did, for example, in the USA, 1 kilogram, $1 in 10 years. You have to put some funding to research, to support the research and development, universities and research institutes. Support the research and development to reduce the cost. So we have the challenges. The cost is high. We have to do research to reduce the cost. Rapid scale up, so we need to increase the size. Enhance collaboration. Collaboration is very, very important. We need international collaboration because this is a global issue. There's climate change, and also there are so many projects all over the world. So we need international collaboration, and also this is important. We're talking about the UA. We need the government, industry, and higher education institution collaboration. So we have to work together on a specific strategies if we want to reach the target by 2050. Establish also a role of hydrogen for a short and long term. See how many million tons of hydrogen do we need by 2030, 2030, 40, and also 50. And we need to estimate what is the impact of this million ton of hydrogen in the energy mix and how you can reach the net zero emission. And we said also that there are so many challenges that we need to work on. Cost of low carbon hydrogen, lack of hydrogen infrastructure. Most of hydrogen is produced right now using fossil fuel, so we need to switch to green hydrogen, and lack also for some regulation, especially for the international standard for safety, transport, and storage of large amount of hydrogen. So this is my last slide. Thank you so much. Repeat the question again.
Yeah, the question. Thank you.
It's in the flight mode.
Recording in progress.
Okay, perfect. So thanks a lot for Dr. Shawky for his presentation. I'm sure it was very insightful for all of you. Now for our next speaker, I'd like to welcome Haja bin Sharada. She's a manager in strategy and generation portfolio management at Taqa, based at the company headquarters in Abu Dhabi. Haja has over 5 years of experience in strategy and management in the power and utilities industries across Europe, Asia, and the Middle East. She has a deep understanding of the sector and specific expertise in supporting strategy decisions and leading transformation programs. So please, we'd like to welcome her, give her all a round of applause so we can start the presentation.
introduction. My name is Hajar Ben Sharada. I'm a manager in strategy in TAQA. Let me say a word about TAQA. I hope most of you know it already. TAQA is the utility company of Abu Dhabi. By utility company, I mean we operate across the value chain of power and water, from power and water generation to transmission and distribution and retail. We have also some operation in oil and gas. And from a geographical perspective, we are of course present and providing power and water to Abu Dhabi, but also we have presence internationally across all continents, in Africa, Europe, Asia, and North America. So for my presentation today, by the way, I haven't prepared slides, so it's going to be just me talking. But I have prepared 4 main key points that I want to talk you through. Actually, 3 main key points that I want to talk you through around green hydrogen and its potential. So first, I want to go a step back and talk about hydrogen market momentum and what kind of potential lies behind this hype of green hydrogen. Second, I also want to share with you how do we see hydrogen as a global opportunity. And here it's important to mention that hydrogen should be looked at from a global perspective, and it has a lot of potential of linking industries but also geographies. And last but not least, and I believe it's a key focus for today, is I will be zooming into hydrogen opportunities in the UAE and how we can leverage on these opportunities. So first, as I said, I'm taking a step back and talking about the hydrogen market momentum. What we see in the world right now is a huge mobilization from governments. So governments worldwide are increasing their decarbonization ambitions, and to that, a couple of numbers. So we noticed that 93 countries now do have net zero targets. That covers over 78% of global GDP. So it's very important in terms of weight and economical weight. 55 countries do have CO2 price schemes in place. That again covers over 80% of global GDP. And specifically to hydrogen, 39 hydrogen strategies are announced globally across continents, and these strategies are announced by governments. So again, hydrogen is key towards this carbon transformation, if we might call it. And again, around hydrogen and what governments are pledging right now, over $80 billion are being pledged by governments for the green hydrogen economy development. So as you see, there is a huge movement from the government side towards decarbonization and specifically towards the promotion of green hydrogen as a key lever for this decarbonization. And on the other hand, the private sector is of course responding and seeing this opportunity. So all of these changes on the government side are driving the green hydrogen momentum in the private sector. So what we have seen is that over 130 companies now are part of the Hydrogen Council. So they are members of the Hydrogen Council, which more than doubled compared to 2020. So again, a huge change or movement is seen in the private sector. Currently, over 110 gigawatts of electrolysis capacity is announced globally until 2030, and over 13 megaton of green hydrogen production is announced until 2030. Or million tons, or not megaton, over 13 million tons of green hydrogen. And in terms of investment, also around $125 billion are announced in direct private investment until 2030. So again, the private sector is mobilizing and moving towards that direction. There are big claims and big announcements being made. So we are seeing here a true transformation in the private sector and in the industry. So that was the first point about the market momentum and where is this economy heading. My second point is around the hydrogen as a global opportunity. As I mentioned earlier, this new green hydrogen economy is to be seen in its global dimension. It does not only link industries, but it also links countries and geographies, and this is what we will see in these details. However, it's important to mention that the green hydrogen economy is still at an early learning stage. So we are still in the stage where we need to invest and see, learn and see, and similar to any innovation curve, we will have an inflection point later in time. So now, as I said, we are still in the early learning stage. The experts expect the inflection point to happen sometime between 2025 to 2030. So yes, there is a lot of investments and there are a lot of commitments, but we haven't reached that maturity and especially commercial maturity stage yet. There is still a lot to be invested in the technology, in the infrastructure, in the value chain, and we are still at that learning stage. So this is very important to keep in mind. On the other side, based on this huge change that we see and this huge movement towards green hydrogen that we see in the economy, global demand for green hydrogen is expected to reach around 20 million tons in 2030, and this will increase significantly after that to around 300 to 400 million tons in 2050. So as we said, this inflection point will happen sometime between 25 to 30, and once that happens and this technology reaches its maturity stage, we will see a huge growth in the demand for green hydrogen. So maybe now the next question is, what are the key uses for green hydrogen? What can we use green hydrogen for? And again, here, this is a global view, so this is not specific to a country, but globally, the key uses of green hydrogen are usually around 4 categories. So first, the first use is for power. So, for example, using ammonia or synfuels, which are based on green hydrogen, or also for firing. So, as you know, you can burn hydrogen the same way you can burn natural gas. And what some people are doing right now is mixing green hydrogen and natural gas to fire, to co-fire gas power plants. So, this is the power use. The second use is heating. So similar to power, we can also either burn hydrogen, green hydrogen, or green hydrogen-based fuels, either for the industry to generate heat, either for the industry or for buildings. The third use or key use is as new feedstock. So one of the key uses or one of the key examples is the use of green hydrogen in steel through DRI. And the fourth use is through existing feedstock uses. So this is not new per se. Hydrogen is being used as feedstock in the industry right now. For example, ammonia, which is based on hydrogen, but greening this existing feedstock with green the industry itself. So these are the key uses that we expect for green hydrogen to be used in. In terms of geographies, by 2030, we expect that Europe will have the highest demand for hydrogen, hydrogen in general, specifically green hydrogen, with around 10 million tons. Europe will be followed by China with around 5 million tons, and Japan and Korea with around 2 million tons. So what you see here is that, yes, there is a global demand, but this demand is not evenly distributed across the world, with again Europe being the key demand spot, followed by Asia, i.e. China and Japan and Korea. And this means that imports of green hydrogen and green hydrogen derivatives will be required to meet this demand. So if the demand is not evenly distributed, we can also expect that the production will not be evenly distributed. So imports of green hydrogen will be required, especially for these geographies that we mentioned before. And to be specific, the key importers for green hydrogen will be, in our expectations, Germany, South Korea, and Japan. And I believe this is a good segue to the third point that I wanted to talk about, which is the potential of green hydrogen and the green hydrogen opportunities in the UAE. So when we talk about import, we of course talk about export. But before we mention or we talk about export from the UAE, let's first look at the domestic potential and what kind of uses can green hydrogen have in the UAE. So looking at the status quo, right now green hydrogen, or not green hydrogen, hydrogen in general is used mainly for chemicals and the refining industry. So this is based on 2020 data. However, if we are to go through this green hydrogen transformation, the green hydrogen local consumption in the UAE is expected to accelerate post 2030. So if you remember, we talked about the inflection point in the whole economy, the green hydrogen economy, and the same is to be expected in the UAE as well. Once we reach that tipping point or inflection point, the demand for green hydrogen will increase. So based on some scenarios that we have looked at, and there is, let's say here, the positive accelerated scenario for green hydrogen, there's an expectation that the domestic demand in the UAE for green hydrogen will reach around 0.2 million tons per annum in 2030, and that will increase significantly in 2050 to over 6 million tons per annum. So again, on what will drive the demand for green hydrogen in the UAE, the expectation is that this demand will be driven mainly by large-scale industrial uses, with new uses still emerging and still to be seen. But the expectation right now is that the uses for green hydrogen will include refining, chemicals, maritime transportation mainly, land transportation, and synfuel fuel production. As you remember earlier, I mentioned briefly export, and that's also a great potential for the UAE. So we said that Germany, South Korea, Japan will be main demand points or main demand geographies for green hydrogen, and the UAE is the key geography where this green hydrogen can be provided. The UAE has also advantages in being a low-cost green hydrogen provider. Actually, the UAE has the fourth lowest cost of production of green hydrogen in the models for 2030, after Chile, Saudi Arabia, and Oman, with the cost of production of hydrogen being around, of green hydrogen being around 1.7 USD per kilogram. And one of the key levers there is that the UAE can produce cheap solar energy. For example, if I compare the cost of production in the UAE, as I said, 1.7 USD per kilogram, to the cost of production of green hydrogen in Japan, which is around 2.4. The key leverage or the key lever there is the cost of renewable energy. And Japan, mainly the renewable energy will be based on wind, while in the UAE is going to be based on solar. So that's a clear competitive cost advantage there for the UAE. Also, not forgetting that the UAE is well connected to these regions in Europe and Asia. and also relatively close to both of them, so that will provide another advantage with regards to exports. So I believe now the remaining and most important questions would be how can you capture this opportunity and what value will this unlock for the UAE? So let us start with the first question, which is how can we capture this opportunity? First and foremost, as we mentioned earlier, enabling access to optimal low-cost clean electricity is key. And this will be mainly from new build renewable energy plants and also from the grid. So optimal low-cost clean electricity is the first lever to capture this opportunity. Second is, of course, regulation. The government intervention is always important when it comes to new technology, which is being developed, as we mentioned earlier in the beginning. So developing a supportive regulation framework and investing in supporting Abu Dhabi's and the UAE's green hydrogen economy. For example, supporting the supply side. For example, green fee waivers, which is seen in Europe and in India, and also supporting the green hydrogen demand side. For example, mandating to blend H2 with natural gas, for example, for co-firing, which has been seen in Europe, or subsidizing H2 vehicles. So these are all levers or measures to support both supply and demand, and this in total will be the government's contribution side to supporting this industry. Third, and also important, is financing. So enabling the competitive financing conditions and tax and import duty schemes for green H2 production is very important. As we said, this is a new technology. Both private sector and public sector need to invest a lot in the beginning to see this industry or this technology reach commercial scale and scale overall. And fourth, also a very important factor, infrastructure. So supporting the development of the infrastructure required to enable the green H2 economy. So that starts from the production itself, the infrastructure for production, and that lies a little bit to the first point on the supply of clean electricity, low-cost clean electricity, that goes to transport, retail, and so on. So supporting the development of this infrastructure across the value chain of the green hydrogen economy. So if I am to summarize the key levers on how to capture this opportunity, low cost clean electricity access, regulatory support, competitive financing, and supporting the development of infrastructure. So now the most important question: what is the value that this will unlock to the UAE? What is in it for the UAE from this whole discussion? First and foremost, and I believe it's also the topic of today's event, is supporting the UAE in its decarbonization journey. As you can think, of course, green hydrogen, as you mentioned also initially, is a key lever when it comes to decarbonizing the industry and the hard-to-abate sectors like transportation, like the heavy industry. So green hydrogen support will be key in this decarbonization journey of the UAE. On the second hand, not only decarbonizing, but it will also support the UAE's economic growth through contributing directly to GDP and also diversifying the economy as a hedge against oil and gas industry rundown. Third, and also also importantly is stimulating the creation of highly qualified jobs through the development and operation of green hydrogen projects in engineering, R&M, development, and so on. As you know, we are now in the early stage of a new technology, and developing that talent and creating these jobs is key for all economies, and those who are fastest to develop this economy will be able to capture these jobs and develop them, and this will give them a competitive advantage in the future when we reach the inflection point and when this economy will grow even further. And fourth, what further value is to be unlocked to the UAE, being on the forefront of new technology, for example, electrolyzers through attracting green hydrogen supply chains and R&D companies. So as you mentioned earlier, this is a window of opportunity for the UAE, giving all the advantages that it had from a cost perspective, from an access to capital, from an access to low-cost, optimized, clean energy, especially in solar. So this will give the UAE the opportunity to be on the forefront of this new technology development. So yeah, if I have to summarize a lot, for once again, what is the value or what value will be unlocked for the UAE? Decarbonization, economic growth, highly qualified jobs, and being a pioneer in this technological innovation. Yeah, that's it from my side, and looking forward to further discussion and questions.
Thank you a lot for your presentation, Hajar. We're going to be going on to our last presenter of this discussion, which is Muthanna. Muthanna is the CEO of Protean, and he has a lot of things to discuss about. Thank you very much, Hajar.
Thank you very much. So I'm going to take the mic. I'm just like Hajar, I don't have a presentation ready, but we will talk it through. So just take it from here.
There's the other PowerPoint that just has the logo.
Yeah, we're good to go. Thank you very much. Thank you very much, Dr. Shawki. Thank you very much, Hajar. That was really valuable information that we benefited from it on the hydrogen industry and the UAE direction where we're heading. I want to go a few steps back, and I just want to talk about what is hydrogen? Why hydrogen? Why are we having this whole interesting seminar here today talking about the direction and the global decarbonization and what is hydrogen has to do with it? So hydrogen is the smallest molecule that we've ever known, so far known to us. It formed 13 billion years ago, just right after the Big Bang, and it's the most abundant element in the universe. The quantity of the hydrogen is estimated about 85% of the global of the universe content is hydrogen. But on planet Earth, we don't have hydrogen in its molecule form. It's always combined with something else, and we have to extract it from that something else in order to use it. It's a very energetic molecule. It has a high energy content as well. Naturally, the nature have used it in two ways. It's used it to fuel stars and as an energy source, as an energy carrier, and also it was used as a chemical compound. And on planet Earth, we find it as on a chemical compound, majority of the hydrogen. And the biggest example of it is the hydrocarbons, which we are all the biomass is built of, requires hydrogen, oxygen, carbon, and life wouldn't be possible without hydrogen on planet Earth. So if we look back in the last 200 years, We've been extracting fuel, the fossil fuels for the last 200 years. Most of our energy sources was based on fossil fuel. Fossil fuel is a biofuel. We didn't make that fuel. The fuel was made by nature to us. We've extracted, we treated, and we used it. That's what we're doing. So we didn't add energy into it. In fact, nature have added the pressure and the temperature to all these biomasses and made that oil for us to use it as a fuel. Now, 200 years down the line, we realize the fossil fuels are not good for us. We have taken so much of this carbon dioxide from under the ground and we've thrown it into the atmosphere. And now we're causing global warming and the climate change, and we need to stop that. So everyone's talking about hydrogen. So why hydrogen? Well, it's not as easy as we think. Hydrogen is going to be the silver bullet. I want to go back and say fossil fuel was made for us. And now we are asked to do the fuel ourselves. So we need to put that energy into that fuel, which is not going to be an easy task. Despite all of the conversation that we had and where the world is heading and the transition, but trying to make our own fuel is not an easy task. It's a mammoth task and requires a lot of energy. On paper it looks really nice, the strategies, the direction that we're setting up, but on ground, the people in the industry, they know how significant is this task. Hydrogen is proposed one of the solutions, but is not the only solution. In fact, I probably to be corrected if I'm not mistaken. Hydrogen is a problem in the global warming at the moment. We are 95 to 98% of the existing hydrogen is a dirty hydrogen. It comes with, it's emitting a lot of CO2 in the atmosphere. And trying to use that hydrogen as an excuse because when it oxidized and with oxygen it produces water, it's not emitting anything else, but actually we are emitting a lot of CO2 when we are producing it. And this is where the color code or the rainbow color codes of hydrogen comes in place. And hydrogen is it's colorless, it doesn't have any smell, doesn't have any sound. Hydrogen doesn't have any color, but we color code them just in order to find out where does it come from, what was the production method of it. So the green hydrogen, which everyone is talking about, that is a hydrogen using the electrons, the molecules, the renewable electrons that we generate either through wind or hydro or solar, and we use those electrons in order to split the water molecules, and in a process called electrolysis. And this is the cleanest form of hydrogen, but it doesn't come without any expenses. Just to put to the audience in the context, how much energy do you need to produce 1 kilo of hydrogen? You need 55 kilowatts of energy just to produce 1 kilo of hydrogen. Now you might say, what is 1 kilo of hydrogen? I would, to put it closer to the audience and to imagine how much is 1 kilo hydrogen, the Toyota Mirai, the most successful hydrogen car in the world at the moment, it has 3 tanks, and between the 3 tanks it carries only 5 kilos of hydrogen, and compressed at 700 bar in order to accommodate that. So hydrogen is not easy to deal with, and it takes a lot of energy to produce, but we need it. Why do we need it? Because our industry, our lives depends on it. We produce almost, if I'm not mistaken, around 100 million tons globally is being produced at the moment. Half of that goes for the ammonia production and the other half for the hydrocarbon cracking in the oil and gas industry. We need the ammonia. Ammonia is important because we need to eat sustainably, and that ammonia needs to turn into at least blue ammonia or green ammonia in order for us to grow our food sustainably. The cement industry and the steel industries, these industries, if they were a country, they would probably be emitting. They would be one of the top 10 emitter countries in the world. And as such, we also need to decarbonize these industries. And in both cases, and these are the highest priority at the moment, hydrogen is not used as an energy carrier, it's used as a chemical compound here. When it comes to the energy, as an energy carrier, hydrogen, it's probably not the most efficient solution that we have. As Dr. Shawki earlier he mentioned, electrification, it needs to have the priority here. Also to put this in an example here, when we consider energy, we talk about well-to-wheel and tank-to-wheel. So when we are talking about the hydrogen and comparing it to the fossil fuel here, we're talking about an energy efficiency that is much worse than electrification. A lot of people, they think hydrogen is actually a solution. It's not really that great solution. It's like a Swiss Army knife. It does almost everything, but whenever you need a screwdriver, you don't grab your Swiss Army knife, you grab a screwdriver because there's always something more efficient than it. There are places where hydrogen has a sweet spot, and we need to focus on that sweet spot. And the UAE have realized there is a great opportunity. As earlier as Dr. mentioned, Europe, for example, they are not really after the hydrogen just because it's a clean hydrogen, but it's also a political stance. There is an energy security for them. They want to stop depending on the Russian and the Middle Eastern oil, so they want to produce their own energy. And for the last 200 years, they felt like they were hostage of anyone who sells them the energy, and now they want to produce it, so they have their own reason to do that. And some of the countries with high potential to be a very cheap hydrogen producers, like the UAE, now they're considering, said, why don't we take this opportunity and sell them the hydrogen, because we can make it cheaper here. So the UAE strategy is mainly focusing on exporting low carbon hydrogen, and that will depend mainly on the blue hydrogen, which is the second type of hydrogen, or we say the third type of hydrogen. The gray hydrogen, it comes from steam methane reforming process, which is emitting a lot of CO2. And if we try to capture some of that CO2, we would call it a blue hydrogen, just because it has a less damaging effect on the environment. There are other hydrogens, different colors. They have the yellow, which comes from the electricity, the brick. We have the pink, which comes from the nuclear. And we have the biohydrogen, which at the moment our company is focusing on the biohydrogen. We believe we need to get back to nature, whether if it's hydrogen, whether if it's a biofuel. Nature will be our safest option. Unfortunately, the UAE does not have a lot of biomass production, and we are at Proto Technology, we're working on that. We're trying to focus on the third generation biofuels and biohydrogen from microalgae. I believe we have covered most of the topics today on the hydrogen, and we would like to ask if there are any questions from the audience. I think we can end it here. Thank you very much for the audience, and hope you enjoyed it. And next time we will have hopefully much more interactive with the slides and with more information. Thank you very much.
Thank you.
Andrew, do you have any questions? Is she here?